Hello and welcome to my Pre-Algebra review series. This video covers Chapter 8, Section 2, entitled Equations with Two Variables. By the end of this video, you will be finding solutions to two variable equations and graphing equations with two variables. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and certainly it'll help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment in the comment section below. I read them and do my best to answer each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Let's look at some equations. In previous chapters, you solved equations with one variable, such as 2x plus 5 equals 7x. In this chapter, you will find solutions to equations with two variables, such as y equals 3x plus 4. An ordered pair that makes such an equation a true statement is called a solution of the equation. So let's go do some. So example 1, let's find a solution. Find the solution of y equals 3x plus 4 for the x value of minus 1. So we're going to start off with our equation, y equals 3x, right here, y equals 3x plus 4, and we're going to solve for x equal minus 1. So in our case, we're going to substitute for x, this minus 1 right here in the equation. And then when we solve this, we're going to say y is equal to minus 3, because it's minus 1 times 3. Minus 1 times 3 is minus 3 plus 4 when you multiply those two out. And then when you add these together, the minus 3 and the 4, you get a 1. So the solution to this is x equals minus 1, y equals 1. So you would write it just that way. The solution of the equation is right here. Minus 1, the x value comes first, and then 1. So x equals minus 1, y equals 1. Minus 1, 1. That's the solution right there. Okay, we have three problems here in Check Your Understanding section. The directions are find the solution of each equation for x equals minus 3. So now we're going to substitute a minus 3 in all three of these equations in the x location. So we start off over here. We have y equals 2 times minus 3 plus 1. Well, when we multiply this, minus 3 times 2 is, minus 6. So we have y equals minus 6 plus 1, and then therefore y equals what? Minus 6 plus 1 is minus 5. So what would the solution be? If we're going to write it like we did before in the previous slide, we have a parentheses, right? We have the x value and the y value. The x value is minus 3, right here, minus 3, comma, minus 5, minus 5. That's the solution. X is minus 3, y is minus 5. Let's do B. So y equals minus 4. Here we have an x. And we're going to substitute minus 3, and we're going to, what does it say here? We're going to add 3, plus 3. So now we're going to multiply this section right here. We're going to multiply it. So we're going to have y is equal to minus 3 times minus 4 is equal to 12. The minuses cancel each other, the even number of minuses, plus 3. Well, 12 plus 3 is 15, so y equals 15. And if we come down to give our answer for minus 3, x equals minus 3, the solution is minus 3, 15. So if you were going to put this on a graph, we'll find out later that the minus 3 is the x location on your graph and the x and y direction, and the 15 is in the y direction. So it would be somewhere, minus 3 would be back here somewhere, and the plus 15 would be up here somewhere. So your dot would be somewhere out like that. Okay? Let's do this next one. Y equals 0x minus 4. This is going to be interesting. So we're going to substitute minus 3 in for x. So y equals 0 times minus 3 minus 4. Well, when we do the multiplication, y equals 0 times minus 3 is 0. Minus 4 is minus 4. So the answer here is y equals minus 4. So when x is minus 3, when x is minus 3, y is minus 4. Well, there's something interesting in this equation, because no matter what value for x we put in, we can put in, what if we put in the value of 5 for x? What would we get? We'd get 0 times 5. Right here, we'd put a 5 in here. It'd be 0 times 5, and the answer would be 0. Here, same here, 0 minus 4. So no matter what number we put in for x, the answer is always going to be, let's say, negative 4. So if you look at this, a little graph, 1, 2, 3, 4, 1, 2, 3, 4, and whatever it is, we'll go out this way, it doesn't matter. The point is, no matter what you put in for x, if you put in a 1 for x, your answer for y is negative 4. If you put in a 4 for x, it's negative 4. If you put in a minus 1,000, it's negative 4. So your answer is always going to be this straight line across here. Always going to be a straight line at minus 4. In the future, you'll see also in the x direction, in the y direction too with a line. But right now, this line goes forever. So no matter what your x value, y is always negative 4. Okay, example 2, real-world problem. You can use two variable equations to model real-world situations. Let's look at one here. The equation t equals 21 minus 0.01 times n models the normal low July temperature in degrees Celsius at Mount Rushmore in South Dakota. In the equation, T is the temperature at n meters above the base of the mountain. Find the normal low temperature in July at 300 meters above the base. Okay, so what do we have here? We have a mountain that goes up so high, right? Mount Rushmore. We know it's got the presidents on it, right? So here's the base down here, okay? And 300 meters, let's say, is right here, 300. So they're saying that equation, this equation here, T equals 21 minus 0.01 N, models the temperature. So if this is where we're starting at the base, and we're going to go up 300 meters, then what we want to know is what's the temperature going to be up here at this high on the mountain. Okay, so we're going to go back to the equation. T equals 21 minus 0.01 times N. And now we just substitute the numbers. Well, what numbers we're going to substitute? Really, we're only going to substitute for N, and we're going to find what T, the temperature, is. So we're going to have T is equal to 21 minus 0.01, let's change the color, times 300. Okay? And when we do that, we're going to find out that the T equals 21 minus 0.01 times 300 is what? It's the same as 0.01 is the same as dividing by 100. Okay? Or multiplying by 0.01, but no matter how you do it, it ends up being 3 equals the answer. 300 divided by 100 is 3, or 300 multiplied by 0.01 is 3. So the answer is so T, the temperature, is equal to 21 minus 3. I shouldn't have done that. Let's go back. 21, shouldn't have got ahead of myself there. 21 minus 3 is 18. So the temperature is 18 degrees Celsius. Okay? So here, in example 2, check your understanding. We're not straying very far from where we were just a second ago. They want to say, find the temperature in degrees Celsius at 700 meters above the base at Mount Rushmore. Use this, it's the same equation. Use the equation from above. So let's go ahead and write this thing. T is equal to 21 minus 0.01 times 700. You can probably see what's coming next, right? So I'll give you time. You think about it. What's the answer? I'm going to start off by rewriting the T equals 21 minus something. Well, as we did before, 0.01 is the same as dividing by 100. Oh, if you divide 700 by 100, you get 7, correct. So the answer now is 21 minus 7 ends up being T equals what? 14. Okay, that's 14 degrees Celsius. Okie doke, there we go. Okay, a second objective for this lesson is graphing equations with two variables. So an equation with two variables can have many solutions. One way to show these solutions is to graph them, which also gives a graph of the equation itself. A linear equation is any equation whose graph is a line. All the equations in this review are linear equations. Example 3, graphing a linear equation. They want us to graph y equals minus 1/2 x plus 3. Make a table of values to show ordered pair solutions. So they're going to let us put our own inputs in, and then we're going to get the derived outputs, and we'll plot them on this graph that we have here. Well, what is it showing? It says we picked minus 2, 0, and 4 are the inputs. X equals minus 2, x equals 0, and x equals 4. And you put those numbers into the equation where the x is in the equation, which in our case right here, the x is right here in the equation. Minus 1/2 x. So here, minus 1/2 x right here, the x plus 3. We substitute the x with the minus 2 in this case. So we have minus 1/2 times minus 2 plus 3. Well, minus 1/2 times minus 2 is equal to 1. The negative signs cancel each other out because it's an even number of negative signs. And 2 divides into 2 one time, so it's 1. And then it's plus 3. So the answer or solution here is 4. Okay? And the position, the plot, is always in the form of x comma y, x being the x position on the graph, y being the coordinate of the y position on the graph. And so in this case, it's x equals minus 2, our input, y equals 4. So down here on the graph, minus 2, there's two notches here, two little ticks for equals 1. So it's over minus 1, that's the minus 1, and 1, am I on the right spot? 4. Oh, 1, 2, 3, 4. Oh, I'm sorry, I misspoke. It's 1, each tick is equal to 1 on the graph. And we have over 2, minus 2, up 4 is this spot right here. Okay, then the next one, we're going to put in the 0, and that means this term disappears, and all you have left is 3. So 0, 3 is a term. So here's 0 for the x, 3 for the y right there. 1, 2, 3. And 4, the next one is 4, the input 4. So 1/2, minus 1/2 times 4 is equal to minus 2. Plus 3 is 1. So now this next one is 4, 1, 2, 3, 4, and up 1, 1, right here. So as you see, the line, the red line, goes through those 3 spots. And those we just plotted every solution to that equation. Doesn't matter whether x is 1,000,000 or a negative 1,000,000. This line is going to fall somewhere, or the answer is going to fall somewhere on that line. Okay? Sorry if that earlier part might have screwed someone up because I had the sizing wrong on the graph in my head. Okay. Okay, example 3, check your understanding. Let's try a few more of these. There's 3 of them. I've got them drawn up here, and we'll just kind of go over the pieces. So in the first one, we have y equals 2x, right here. Y equals 2x plus 1. So we're going to substitute in for the x value, right in here, the x value. We're going to substitute in a -1, a 0, and a 1. And the answer, and the y value that comes out of this equation is -1, 1, and 3. So like if you take -1 right here, put it into this x value. Let me erase this so you can see it a little better right here. Okay. If you take and put -1 into the x value, you get -1 times 2 is -2, plus 1 is -1. Right here, -1. Put 0 in. 2 times 0 is 0, plus 1. X value 0, y value 1. The next one, you put a 1 in with the x, and 1 times 2 gives you a 2, plus 1 gives you a 3. So these are the 3 points. X -1, y -1. So the first one, -1, comma -1 right here. This one right here, pointing to it right here. Here's -1. I go 2 ticks over for each, for 1. So -1 down 2 is -1. So there's the first one. The second one is 0 and 1. So here's the 0 on the x right here, the 0 spot right here, 0. And we're 1 up. So 0, comma 1. And the last one is 1, 3. 1, comma 3. So 1, you go over here, 1, 1, right here, and you go up 3. 1, 2, 3. I guess I'm off a little bit, but it's right here in this area here. And then we draw a line through it. And as we said before, this line is every solution to this equation. So no matter which number you pick, if you come over here and pick, here's 1, 2, and you put a 2 in, and SI 2 is 4 plus 1 is 5, and so here's 2, 1, 2. So if I go down, by the time I come down here, and it's going to cross at 5 way down, it's going to be down here 1, 2, 3, whatever the case is, it should be way down there. Okay? The next problem, B, y equals 3x minus 2. So we replaced in here with the x equals minus 1. We're doing the same numbers each time. -1, 0, and 1. This time we get y is a -5. And y is a -2 when x is 0. And when x is a 1, we get y equals 1. I put them in here. -1, -5 is that way down here. -1, -5 way down here. Here it is. The next one is 0, 2. X is 0, -2. And it's -2 is right here, approximately on the graph. And 1, x1, y1. x1, y1 right here. Draw a line through them. These are the solutions of this graph. Of this equation. By graphing, you can pick out the solutions. Problem C, y equals -1/2 x plus 4. Okay, -1, 2, 0, and 1. Same as all the others. So when we put a -1 up here, we get a positive 1/2, right? Because the negative signs cancel each other. So it's a positive 1/2. 1 divided by 2 plus 4. 4 and 1/2 is the y value. And then we go here, we put a 0 in for the x. This term goes to 0 right here. The whole term goes to 0. And we're at 4. So 0, 4. When there's a 1 here, it's -1/2 plus 4. is 3.5. So here's 3.5. So our y values are going down. As you see, the graph is going down. The slope is negative. And the values are -1 and 4.5. Here's -1, 4.5, right up here. -1, 4.5, right in this area here. And then there's 0, 4, 0 on the x, and 4 is right in here. Okay, and then the last one is 1 and 3.5. Here's 1 and 3.5, right in about there. The line goes through them. Here's the line. Again, the solution, all the solutions for this equation. And you've graphed a line now. You've looked at it. You can take if you just had the dots, you could take a ruler and kind of draw with your pencil and draw the line through there. Okay? Okay, in example 4, we're going to be talking about graphing y equals a and x equals b. Graph each equation. Is the equation a function? Remember from our discussion on relations and functions? What's the definition of a function? A function, each x has one independent y value or output. So you can't have an x with two different values for the output y. A relationship is you can have multiple solutions for a given x. So that's basically what we're talking about here. So let's look at the equation here, y equals 2. So what does that say? It says if x is 0, I'm drawing a 0 point here, y is equal to 2. If I say x at 1, 2, 3, 4, if x is 4, at x is 4, y is equal to 2. Okay? I can do any point. I just pick a point at random. You draw a line up. Each point on the x-axis only results in one answer. It never results in two different answers. The answer always happens to be 2 in this case, but that's perfectly fine. This is a horizontal line, and the equation y equals 2 is a function. So a horizontal line like this, horizontal to the x-axis, well, actually horizontal to any axis, but in this case, we're looking at x. It's a function. The next equation, b, says x equals 2. This first one was y equals 2. This one's x equals 2. So when x equals 2, here's x. There's only one x we're looking at. How many values does x have? Well, x could be 1, 2, 3, -1, -2, -1,000,000. It doesn't matter. X has a million, billion, infinite number of solutions. So it's a vertical line, and the equation x equals 2 is not a function. Okay, we're going to do a little checking our understanding with example 4 here. Graph each equation. Is the equation a function? Same as we just did. And we talked about these. A, x equals 1. Is it a function? Is it yes, a function, or no, it's not? Well, if x is 1, here's x. Right here, we'll call it 2 ticks over as being 1. It's a half per tick. So this is x equals 1. What's y? Y is anything we want it to be, right? So we talked about this. And it's going to be hard for me to draw this, but I'm not good at drawing these straight lines. Anyways, it's like this. Up and down, straight, excuse me, being crooked here. Up and down. So this is not a function because x has an infinite number of answers. So it is not a function. How about y equals -4? 1, 2, 3. I say 1, 2, 3, 4. So just try to draw it across here. Excuse my crooked line. It doesn't come out very good, does it? Not really a straight line. I am not good at drawing these straight lines. Can I erase that? No, it won't let me do it that way. Let me erase that and try it again. Let's see if I can do it a little faster. I don't know. Maybe it's just speed here. We're going to go right at here. Let's assume that that's 4 right there. So here, every line, we have a horizontal line. So no matter what value of x we pick up here, no matter which value of x, we always get an answer, but only one answer. So no matter if you have a value of x and you can only get one answer, you have a function. So this is a function. So the answer here is yes. And how about this one here? X equals 0. So what is this telling us? Here's x. Here's 0. X is 0. Well, isn't that very much like here, x is equal to 1? It's kind of like a trick question, so to speak. It's kind of like x equals 1, x equals 0. It's the same difference. You're still going to get, x can be, you get a zillion, billion, whatever. Here, I'll just draw a line like that. Not great, but you can see it. So this is not a function. Okay. Okay, example 5, graph by solving for y. Now they want us to do everything, right? We're going to solve. We got the equation. We're going to solve for y. And then we're going to plug in some values and get the points on our graph. We're going to pinpoint them on the graph. And then we're going to draw a line through it so you can see the line that the representation of this equation up here that we're graphing. And this is a straight line, and there it is. So it says graph 3x plus y is equal to minus 5. So what's the first thing we have to do? So we'll start by writing the equation, writing it out, so we have a place to work from. Then we're going to add plus 3x to each side to get the x to the right side. We want the y on the left side, because now y is going to be this answer to our problem here. So when we do the addition on each side and simplify, we're going to get y equals minus 3x minus 5. Okay? So now we're going to plug in some values. I chose minus 2, minus 1, and 0. I guess I'm not sure if I chose it or not. That's what I wrote down. And when we solve the equation, we get minus 3 times minus 3 times minus 2 is 6. The negatives cancel. 6 minus 5 is 1. So our solution is minus 2 comma 1. X is minus 2, y is 1. Now we'll do the next one, minus 1. So minus 3 times a minus 1 is 3. Minus 5 is minus 2. So now it's minus 1 comma minus 2. X minus 1, y minus 2. Now the final one, 0. X is 0. So when x is 0, 0 times anything is 0. Minus 5 is minus 5. So the final solution is 0 comma minus 5. And it looks like I missed a parenthesis in here, but I guess it don't really matter. I shouldn't have drawn that in. I'm going to erase it back out. Not important. Okay, so now I go over here and I plot them. So here, one of them is minus 2, 1. Minus 2 is 1. Oh, get my ink pen back. 1, 2, and you go up 1. So here's that one. That's the first value. Right here, first value. The next one is minus 1, minus 2. So now we're minus 1, which is half 1, down 2. Right here. So here's 1, 2. So we're going to go right here. Up, down from here, over from here. Okay? And then the final one is 0. Here's 0. Minus 5. So we're going to go way down here to minus 5. 1, 2, 3, 4, minus 5. We're going to put our line through it. And there's our solution. There's the line, the graph of this equation up here. And we got that graph by doing a couple points. And for your own information in the future, you only need 2 points to get that graph. But we'll go with 3. Helps. We have to do the problems anyways. Okay? Okay, example 5a. Check your understanding. Directions. Solve each equation for y. then graph the equation. So we've already done this here. We got the graph, and we're just going to talk about it. Just going to go and think about it. How did we get the numbers, and why did we pick the numbers? So we start with 2x plus y equals 3. So that means we have to remove the x's. Let's get the x's off the left side and put them on the right side. In order to do that, we have to add a negative 2x to each side, right there. And when we do that and we simplify, we're going to get y equals minus 2x plus 3. So now we have to graph it. How are we going to graph it? Well, one of the things we can do is that it's pretty obvious. We should pick somewhere around, picking 0 is quite helpful at times, because look at this. If I put a 0 in for x, right here, for the x value, I get 0 times negative 2, and I get 0. So what does the y end up being? Y ends up being 3. Pretty straightforward. So look at, go down here to 0x, and go up 1, 2, 3, 1. I'm doing 2 ticks per count. 1, 2, 3, and here we are. The x-axis is, the axis line, or the line is crossing y right there at x equals 0. Then let's add 1 to that. So now let's do, so we have 0, comma 3. The next one we're going to have 1, comma something. We're going to find out what that is. And then let's do 2, comma something for the last one, okay? So if we put a 1 in here, we're going to get a negative 2. Negative 2 times 1 is equal to, plus 3 is, negative 2 plus 3 is 1. So 1, 1 is our solution for that. And then the next one, if we put a 2 in here, we're going to have a negative 4. 2 times negative 2 plus 1, plus 3 is negative 1. Okay, negative 2. Oh, where did I go? Sorry, I'm 2. 2, negative 4 plus 1 is, plus 3 is 1. So that's going to be down into here. The other one was right about in here. 1, 1. 1, 1 is right here. And this one here is going to be negative 1. So here's 2, 1, 2, down to here, and 1. So our dot's right there. And as you see, that falls on the line. And that line is the graph of the entire equation for every solution. If you pick negative 1 for your x value, you could go up here at negative 1 and find out what this is. At negative 1, it's about, I don't know, I could solve it. Well, let's do it. Negative 1. Negative 1 times negative 2 is positive 2. Plus 3 is 5. So if I go negative 1, 1, 2, 3, 4, 5, right across from here, that should be out to the 1 right there. See? They line up. Okay, the next one, B. Y minus x equals 5. So we have to move this negative x to the right-hand side, so we have to add a positive x to both sides. So y equals x, the positive x, plus 5. So what do we choose? Well, like we did in problem A, we can go here and set x equal to 0, because that's going to get him out of the equation. All you're going to have left is the 5. So we go up 5. 1. This is 1 tick per count in this one. 1, 2, 3, 4, 5. Okay, so here we have x equals 0, y equals 5. The next one, let's go negative in this one. Let's go negative 1 and negative 2, I guess. Give it a shot. See what it does. So if we put a negative 1 in here, negative 1 plus 5 is 4. So here's negative 1 is, I said these are 1 per tick. 1. I'm out 1, 1, 1, 2, 3, 4. Here's the 1, 4 right there. They're kind of close to each other. If we did negative 2, what would be this one? And negative, this is going to be 4. And negative 2 plus 5 is 3. So this is 3. So negative 2, 1, 2, up 3 right here. So they're all kind of close, but as you see, they all land on the line. Okay? Okay, so check your understanding. Example 5b. Direction, solve each equation for y, then graph it. So in this case, we have negative 3x plus 2y equals 6. So we have to do as usual in the past. Now we have to move the x to the right-hand side to get the y by itself on the left-hand side. And to do that, we're going to multiply, or not multiply, add each side plus 3x to get rid of the minus 3 on this side. So we're not, now when we simplify that, we're left with 2y equals 6 plus 3x. So now we have to get rid of the 2, and to do that, we're going to multiply by the reciprocal of 2, which is 1/2. But that, when you do that, the 2 divided by a half, or times a half, is going to be 1. So we'll end up with 1y. And then we have to multiply the right-hand side by a half. But the entire side has to be multiplied by a half. So we're going to put parentheses around the entire side. And it looks now like the distributive property. That whole thing is times 1/2. And when you solve it, 1/2 times 6 is 3. And 1/2 times 3x is 3/2 x. So now let's pick a value. The first value I always like to pick is x equals 0. So I like to pick x equals 0. And if I pick x equals 0, and we're going to go with 2 ticks per count. So 1, 2, 3, like that. 2 ticks. 1, 2, 3. So if it's 0, if the value for x that we chose is 0, then y ends up being 0 times 3/2 is 0, plus 3 is 3. Right here, 3. Okay, so 3. Next one. Let's pick minus 1. Minus 1. In fact, let's pick minus 2 for the next one. Okay, so x equals minus 1. If I put a minus 1 here for x, I get minus 3/2. So 3 plus minus 3/2 is plus 3/2, because 3/2 is 6/2. 6/2 minus 3/2 is 3/2. So now, when it's negative 1, it's 3/2. Okay? And then, when we put a negative 2 in here, negative 2 at the x position here, so it's 3/2 times negative 2. Well, that makes this whole term negative, because there's one negative sign. And the 2 for the x cancels out the 2 in the halves. So that becomes 1. So now you end up remaining with 3. But it's negative 3. So 3 plus a negative 3 is 0. So when you go out here, x equals negative 2, 1, 2. The y value is 0. That's the y value. And so that's going to be 0. 0 right there. Okay? And 3/2, if I'm out 1, here, these are halves, 1, 2, 3. If I go over here to here, you'll see that's right above 1. It's the 3/2 spot. Okay? So there's our line drawn the graph. The solution for every solution for this function is graphed right here. And these are functions because every x value has its own independent answer, y value.